Hey everybody, this is Larry. This is day 8 of the Leetcode Day Challenge. Hit the like button, subscribe button, join me in Discord. Let me know what you think about this one. I was just reading your comments from yesterday about the stock market. I just thought it was easy. And apparently this is a easy problem. But I didn't gym exercise while honestly I gave myself a break. So this yesterday I ran and I ran hard. So I just kind of be like, all right, let the body rest a little bit. The stock market was crazy though, right? And also the White Lotus ending. Let me know if you watched either one of those. The stock market was just nuts. I don't even know what I would say. It went from down, like really down, to really up in a split second, and then really down again, and then just like flat all out. But and I was there during all of it, so it was kind of been a little bit nuts. But it is kind of one of those days, you know. It's and don't get me wrong, I'm still down a lot of money. So, but it's just sometimes just being able to survive is good enough. Live to invest another day, and that's how I think about it. Because sometimes, you play the maths, you play the probabilities, and hope they go well. But it is what it is. All right, let's take a look at today's problem. We have 3396 minimum number of operations to make elements in a way distinct. And also, I will have another video for the weekly premium challenge, so definitely check out that. Check afterwards in a different video. Yeah, let's see. Okay, so you're given nums. You want to make sure everything is distinct. Okay, we moved 3 elements from the beginning of the wave. It has to fill 3 remove all of them. Note that an empty array is gonna return the minimum. Okay. If you move the first, it's 3 return which has the same element. The element is 2. Okay. I want to take the n, and given that n is small, you can certainly just do a while loop, right? Meaning that, okay, like maybe a while loop will look something like this. While length of nums is equal to length of set of nums, or while this is not true, maybe you do like operations is equal to 0, right? Then we have to do one operation, then nums is equal to nums of something like this, right? Yeah, and something like that, and you could certainly do something like that, but it's not quite fast, right? Because here, this is an O of n operation, this is an O of n operations, this loops O of n times, because every time you're removing 3 elements, so yeah, you get to, you have 4 of them in due time, right? So you certainly can do that, right? But but I think but yeah, I think so yeah, you certainly can do this. This is n squared because sorry, I'm dealing with allergies and yeah, and just breathing. But yeah, this loop takes all of n time, or this loop will execute all of n times, so this also takes all of n times because of we converting into a set. This is O of n, so it's going to be n squared, right? And n squared is fine because n is 100. But you can actually do this in less than n squared time, right? You could kind of do it, well, backwards. It's a little bit tricky because of the fewer than 3 thing. But it's just about working it backwards in terms of, basically, if you think about, okay, we're chopping the prefix until the suffix is unique, right? That's basically what this problem is saying. But you can also do it backwards by building backwards from the suffix until it is no longer unique. So that's basically kind of the idea that it would have. It's a little bit tricky, like I said, because if the number of elements is not a multiple of 3, you have to kind of be a little bit careful. But otherwise, okay. So maybe we'll give a quick spin doing something like that, right? So here, maybe right, and then yeah. How would I want to? And counting is a little bit tricky, but it's not that bad, I think. Basically, the max operations, right? It's going to be, so max ops is going to be equal to, just divided by 3, right? So n divided by 3, but we will round it up. So we want something like this, right? Want to round it up. and then here, maybe we have n mod 3 is the leftovers for the first turn. So something like getting the index right is a little bit awkward, but I think it's fine, right? So here maybe you have seen just for duplicate checking, and then now for I in range. Maybe something like this, right? Maybe max ops, we could say, and then we just do it backwards, right? So here we have num sub I times. We want to count backwards, so it's actually something like this, right? N minus this. Yeah, right. Minus 1. So these are our 3 numbers, right? So something like that. Maybe something like j in range of 3, just so we can write this a little bit easier. So it'll be minus j minus 1, because to do the last 3 elements, and we want to make sure that this is, well, that this is within bounds, right? No, I mean this, well, it's true, but this is actually a little bit off, because n minus or this is always going to be, because this always gets the last 3 elements, but not the last 3 counting leftovers, right? Counting these leftovers. So it's a little bit trickier to kind of get this quite precisely right. So maybe I would just write, okay, offset is equal to max ops minus I. So maybe we could count it backwards. Times 3. Is that a this or plus something like that? Maybe let's see. Right, max ops times 3 would be. I think it is. So if I is 0, then it'll be max ops times 3. So I think it is actually minus 1. Could be wrong here. And then now this is just, yeah, offset plus j, right? We want to check that offset plus j is less than n. If then, yeah, and then we can check if it's in here, right? So good is equal to true. If this number is in scene, then good is equal to false, right? And then otherwise we just add it to scene. Again, this is, as you can see, much more trickier. But yeah, so if not good, then we just then we did I number of operations before this is not good. So then like we return max ops minus I or something like that. Otherwise the entire array is okay, so then we just return max ops minus max ops, which is 0. Something like this. Maybe it's off by 1, but the idea is kind of like that, right? Hopefully that makes sense. Let's give a quick submit. Hopefully it's right and I didn't have a rounding off by 1. And as you can see now, this is much faster. Because why? Because, well, this is linear time, right? Linear time, linear space due to the set, and that's it. Yeah, that is all I have for this one. I've solved it for you. Let me know what you think. Thanks for watching, and yeah, hope the stock market treats you well, and hope it treats me well, so that I could keep on doing these videos. But stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.